Hello, I think I'm ready now. Can you hear me? Do you see the desktop?
Yeah.
Okay,
Yes.
okay, thanks. All right. The university changed the way Zoom works, at least for faculty, and now I have to log into Zoom every time I start a Zoom meeting. That actually slows me down a lot. But now I have to log in, authenticate, type in a couple different passwords every time I start a Zoom meeting. Okay, so you should feel a lot safer now. Okay, so uh, we're going to start talking about the stuff for homework too, which is the new chapter in the. We're going to start talking about some of the ideas from the operating systems. So we're going to start talking today about processes. Okay, but we're not going to actually say much about what's in this chapter. We're going to first introduce processes in Windows. So we're going to really see what we mean by processes from the point of view of people using the computer. And then we'll talk, this is more about the theory of processes from the point of view of the operating system. So what we're first going to do is approach it from the point of view of a user of the computer. Like what is it that you can know, what can you, how do processes affect the way you use the computer? What is a process from a user's point of view? And we'll look at homework 2, where you're going to write code that manipulates Windows processes. And then after we looked at how processes work from a user's point of view, and then look at the code, how they work from a programmer's point of view, then we can start talking about how they look from the operating system's point of view, from the theory of the operating system inside. So first it's the user's point of view. So essentially we're going from the top down. First the user's point of view, then the programmer's point of view, then the operating system's point of view. And in the textbook, let me go to the table of contents of the book. This is the material about processes. See, they got these bands. This is processes, this column here. This is virtual memory, this column here, this column here. I don't know why. Well, they just called this virtualization. This year said virtual CPU, and this column should have been virtual memory. So this column is the virtual CPU. This column is virtual memory. Then this column is concurrency, and then this column is file systems. Okay. In this column on virtual CPU, there's processes. This chapter is pretty neutral in whether you're using a Windows or a Linux. It's the theory of processes. This chapter is Linux processes, which we'll skip over because we don't have Linux computers. We have Windows computers. But this is the programmer's point of view, the application programming interface to Linux processes. So we're going to kind of we're essentially doing this in the reverse order. We're going to do chapter 5 first, but for Windows. It'd be kind of nice if he wrote a version of chapter 5 for Windows, but most people who teach this course teach it using Linux. Okay, so the chapter 5 is the programmer's point of view of processes, and then he's even got you can download his code. The code's up. He's got a repository on GitHub where he's got some programs, and we're going to do. These are the Linux versions of what we're going to do in Windows. This is how you write Linux code to interact with processes. Okay, so we probably won't. We might actually do a little bit. We might say a few things about that later on, but we're gonna start by talking about processes in Windows. Then we're going to do processes, programming them from the Windows point of view. Then we'll go to chapter 5, and then chapter 6 is back to being theory. So chapter 4 is true for both Linux and Windows or any other operating system, Android, any operating system you look at. Same with this. This is about processes in general. All of the rest of the chapters are about processes in general. Okay, so this is the only Linux-based chapter. Okay, and there is no Windows-based chapter in this book. Okay, and the same is going to be true for virtual memory. Uh, the code is for Linux, but we're going to do things with Windows. So we're going to see, like the memory API is really more about Linux. They use the Linux application programmers interface. We're going to use the Windows API. Okay. Same over here when I talk about concurrency. This thread API is the Linux API, and we won't get this far. But if we were to do this, we would be using the Windows API, not the Linux API. Okay. All right. So okay, now let's start talking about actually, let me download this zip file And I might as well go to the homework page. I don't know if we'll get to it today, but I can download the homework 2 zip file. Okay. Now, let's see. Okay. So, okay, what do we mean by a process? Let's just start off by what do we mean by a process? Okay. Now, the real thing we want to do is start playing around with Task Manager. Um, let me, well, first, actually, let me first use this file export. Programs that come with Windows, like Notepad or like Notepad, they tend to be stored in this directory. There's two places where Windows stores programs that you can run. Okay, so on your C drive, there's a folder called Program Files. Now, this is the folder that holds programs that you install. Some of these were put there by Windows when it was download when you first installed Windows, but most of what's in this folder are things that you install as you own the operating system. Okay, and these are 64-bit programs, and these are 32-bit programs. Okay, so there's another program files folder that has 32-bit programs. Okay, most computers these days are 64-bit CPUs, but there's still a lot of software around that was written for 32-bit CPUs, and it's still and that's where Windows puts them. Now, this is the stuff that you install for the most part. On the other hand, this folder here is the Windows operating system. Okay, so this is stuff that's put there when you install Windows. And a lot of the programs, for example, that are in your Start menu are actually in this folder. They're not in the Program Files folder, they're in the Windows folder. More specifically, they're in this folder called System32. Okay, you double click on this, notice that there's almost 5,000 files in this folder. There's almost 5,000 files. This is essentially the operating system. This stuff gets all put there when you install Windows. Okay, and a lot of the programs you use that come with Windows are in here. So here's Notepad. See, if I double click there, I'm running Notepad. Okay, so that's the simple editor that comes with Windows. That's where, see, it's not installed it's not installed in the program files directory because it was put there when you installed Windows first on the computer, when the manufacturer usually does the install. So it's part of Windows. And there's a whole bunch of programs in here. Some of them are GUI programs, and some of them, see, if like this one here, if I double click on it, it's a command line program. Okay, it's called MS lookup, name server lookup. It lets you look up names. It's a real useful tool. It lets you look up names and you find out what their IP address is. Like the IP address of Purdue is this. Okay, so if I want to know the IP address of Google, it tells me what their IP address is. Okay, so that's a command line program. So some of these are GUI programs and some of them are command line programs. Now, some of them are actually pieces of the operating system. If you double click on them, nothing will happen. And because they're really not user programs. The majority of what's in this folder are pieces of the operating system, and it's scattered here and there are programs that are user programs. I'm looking for one. There's a user program. This one lets you look up any character in the Unicode's character system. It lets you look up every character in every font that's on your computer. So it's called Character Map. Okay, it's a little tool. If you're looking for strange character, if for some reason you're working on a Word document and you want to type something in Thai, you can find the Thai alphabet in here somewhere, and you could type anything you wanted in that. If you wanted to type something in Hebrew, You could, if you knew where to look, you'd be able to find the Hebrew alphabet somewhere in here, and you'd be able to type some characters. So it's called the character map. It's letting you introduce, it's for letting you put into documents characters that you don't have on your keyboard. Okay, so that's a tool that comes with Windows. Normally people go over here and they type care map in the start menu and they click on that. And that's how most people get to this stuff. Most people don't know where these programs are. Same with Notepad. Most people would just go up here and type Notepad. There's Notepad. There's how I start Notepad. Now, when I do this, what shows up here is a shortcut to this guy over here. I lost it. Where is it? There. This is what we call the Notepad program. It's an executable file. Okay, we call that, and we're going to use terms in a very specific way in an operating systems class. When you use words in real specific ways, sometimes people refer to them as terms of art. When you're using a word in a technical way, not the usual way people use it. So this thing, an EXE file on a hard drive, we're going to call that a program. Okay, it got there by compiling a source file. Microsoft has a source file, notepad.c, and when they compile it, they get notepad.exe, and they call this the program. Okay. Now, when you search for something like this, whoops, this is actually what we call a shortcut to that one there. That's not the Notepad program. That's an icon or a shortcut to the real Notepad program. This is the same thing as if I did the following. Like, for example, I can go over here and I can create a shortcut to Notepad there. Okay. And then I can do this. And that's not the Notepad program. That's a Notepad shortcut. That points at the Notepad program. It's a reference to the Notepad program, but I can use it as if it was the Notepad program. Okay. I can delete this, and it doesn't hurt me. If I delete this, I've lost Notepad. Okay. If I delete this, it's not a good thing to do. I'll have lost Notepad. I don't think it'll even let me delete it. No, see, it won't let me delete it. I mean, it will let me delete it, but it says, see, this is a protected folder. This folder is part of your operating system. No one's supposed to actually put things in this folder or remove things from this folder. If somebody could put things in this folder, they could put, and this is exactly how a lot of viruses work. They try to implant manipulated versions of these programs in this folder so that when you run them, you're running the manipulated versions, which are essentially what viruses are. So this folder is protected. You're not supposed to be able to put things in it, or for that matter, delete things from it, because that would be one way to attack the operating system, to manipulate the files in this folder. Okay, so we can create shortcuts to these things, and that's pretty much what, when you use this menu item here, you're getting shortcuts. I mean, those are really shortcuts that are built into the menu, to the start menu, that point at the programs that are on the file system. Programs are EXE files on the file system. Okay, and if you notice that, like, look at care map, a little detail. Notice when there's 5,000 files in a folder, it can get hard to move around in it. Notice that the program is actually called CHARMAP, but it advertises itself as character map. Okay, if you looked for a program called character map on Windows, you wouldn't find it. There is no program called character map. The program's called CHARMAP. Okay, but if you right click on it and ask for its properties, under details, see file description, character map. That's what the start menu is showing you. It's showing you this title for the program, but the program is actually CHARMAP, and we're going to see as we go along. That's important. The fact that the program is called CHARMAP matters to the operating system. The operating system doesn't know anything about character map, but it knows about this program, this executable file. Okay. All right. Now, here's another thing that if I double click on that, I run that program. If I double click on it again, I'm running it again. If I double click on it again, I'm running it again. Well, what does this mean? Okay, there's a little bit of trickiness going on here. See, I've got 3 of these windows open. Okay, now on the other hand, I could have multiple Chrome windows too. But it's not quite the same thing though. Okay, see, I have multiple Chrome windows here, and I have multiple. See, if I go here, my start menu starting to fill up. See, I have multiple character maps, and I have multiple Chrome windows, but they're not quite the same thing. Okay, what do I mean by that? Now let me take this tab and put it back over here where it was. Okay. Okay. Now I'm going to start up task task manager. So if you go here, you can. There's something called task manager. Okay. Now I have it started up on my other window. So let me drag it over here. Okay. There's my task manager. Uh, One way to bring up task manager is to type Control Alt Escape, or I'm sorry, Control Shift Escape. If you hold down the Control key and the Shift key and hit the Escape key, you'll bring up the task manager. So for example, if I minimize that and if I type Control Shift Escape, see it popped up. I don't know if you can hear me, but I'm actually minimizing it. And I'm not moving the mouse. I'm not doing anything with the mouse. With the keyboard, I'm doing Control Shift, then I hit Escape, and the task manager pops up. Okay, so that's an easy way to bring up the task manager. If I go to this list details, not this, also we're talking about processes, and there's this tab called processes. That's a misnamed tab. That is not the tab of processes. Okay, well, it's kind of is, but it's not a useful tab of processes. It really, it's not a very good, it's kind of weird the way this is set up. Instead, there's this tab called details. This is the list of processes. See this column, PID stands for process ID. This is the list of all the processes that are currently running on my computer right now. Now, what do I mean by that? Let's go back and close these. Okay, and go to, see, I need more windows. Okay, I'm gonna go to note, oh, well, care map. Okay, right now I have all these processes in alphabetical order. If I go here and I double click on care map, it's running now, right? And now it shows up in this list. There. Oh, there's 2 of them up there. Let me check something. Okay. There's a care map program. If I double click on it, what I'm doing is I'm creating a care map process. Program means file on your hard drive. Process means program running in memory. What that did was when I double clicked on this program, the Windows operating system copied the EXE file, which is the binary executable, into the computer's memory and created what we call a process out of it and gave that process an ID number, and see it's currently running. I'm logged in as Classroom. I created a user account for myself called Classroom that I use as the desktop for when I'm doing these Zoom meetings. Okay. Now, if I do this again, I've instantiated another process from that program. And if I do this again, I've instantiated another process from that program. So now I've got 3, we say, instances of this program as processes. That means this program is copied into memory 3 times. It was copied into memory once, twice, a 3rd time. This is kind of a dumb program. It doesn't know how to share windows. Now, some programs, when you have multiple windows of them up, they're actually sharing one process. Okay. See, this one is not sharing one process. It's actually 3 separate processes. So it's using 3 times the memory of just one of these running, okay? Because it's a real simple baby program. Notepad is the same way. I just created a notepad process. So I go down here. There's the notepad process. If I go over here and say end task, it should say end process. I'm not sure why they call it a task. It says, are you sure you want, now here it says end process. Notice it over here. They're not consistent about this stuff at all. I say end task and they say, okay, end process. Well, why didn't they just, figure out that this thing over here should have been end process? So I'm terminating that process that was created. Okay. See, and then to start it back up again, I go back here and I double click. Okay. Yeah. And then I got that. And then if I double click again, this is kind of a dumb program. So if you run every Windows notepad, every notepad window is its own process. Every notepad window is a separate process. So now I've got three. Notice that they have three different process ID numbers. From the point of view of the operating system, these are three completely independent processes running. They happen to be all from the same program. Now, this is an interesting analogy. A program is to a process almost exactly like a class is to an object in a language like Java or JavaScript, an object-oriented programming language. You instantiate objects from a class by using the new operator. In Windows, you instantiate a process from a program. Well, the question is how, what really instantiates? What's the new operation? And that's what we're going to talk about in a little while. What is the thing that is the new what is it that says I want a new notepad? It's not me double clicking here. Okay, me double clicking here is just, I'll show you, for example, it's got nothing to do with double clicking. So let me create some more notepad processes a different way. So what I'm going to do now is I'm going to I lost notepad. Okay, see if I can open a command window here. And I type notepad at the command window. Okay, see, I didn't double click on anything. I typed a command line. And if I'm at the CMD prompt and I type the name of a program, CMD runs the program. Okay. Okay. Now notice I've got a whole bunch of instances in Notepad. Some of them were created by typing Notepad at a command prompt. Some of them were created by double clicking on Notepad here. I can also create another Notepad instance by doing Notepad here and clicking on that guy, which is a shortcut. Okay. So now I've got in Task Manager, I have all these instances of Notepad, and they got there by different reasons. They got there different ways. Okay. Now, if you notice, they don't quite see under here. I had some. Now, Task Manager shows you lots of columns. If you start up Task Manager on your computer, it probably doesn't look like this because I've chosen which columns to show. If you right click on one of these tabs, where is it? Oh, I'm sorry, not the tab. No, if you right click on these headers, it's confusing. If you see these tabs, the tab we want to be in is the Details tab. The Details tab has all these different columns. If you right click on one of the columns, you can select columns. So I've got a certain number of columns selected. Okay. A real important column to select is command line column. Okay. Select the command. We're going to be talking about that one. And as we go along later on in the course, we'll use more of these columns. If you turn on all the columns, you get way too much information. Like a real important column you should turn on is PID. I don't think it's turned on by default in Windows. So you should turn on that column. I don't think it's turned on by default. You should turn on the command line column. I don't think it's on by default. If I remember right, the description column is on by default, and it's kind of a useless column. so I turn it off because it takes up a lot of space. The command line column tells you more information than the description column does. But sometimes there'll be some information in the description column that isn't maybe in the command line column. So you might, I think that column is turned on by default. You could turn on the GPU column. If it's a program that's making use of the GPU, you can get a little bit of information in Task Manager about the GPU if you need that information. So from our point of view, the ones that are important are the process ID number, status, CPU. That's how much time. That's what percentage of the CPU your process is using, how much memory your process is using, and later on this semester we'll be talking about these things called page faults, okay, and priority. We'll be talking about page faults and priority, okay. So notice that these different notepads don't have the same command line over here. It's kind of funny. We'll talk a minute what that thing is over there, okay. All right, now so a program is a file on your hard drive. When you double click a program and you run it, you create a process. So now I created this NS lookup process. So there's NS lookup process running. And over here, I could, if I want to, end it. Okay, I can go back over here and start it up again. And we'll see. If I double click on this one again, I get another one. And NS lookup is a simple program. So every time it creates a window, it creates another process for that window. So there's one window per process. I'm trying to remember of a program that would be a little bit smarter. We create an empty Word document. Okay, it started up on my other monitor for some reason. Okay, there's Word. I started a Word process by double clicking on an empty Word document. Okay, now let's look in Task Manager. I can't remember what, I think, let's see. Oh, it's probably MS Word. Let's see if it's called. See, remember the name of the name of the process is not usually the name of the program. Like we think of this as Word, but what is the process? The process, let's see if I can find it. I'm not even remembering what, I thought it was WinWord. It was, oh yeah, that's it, WinWord. Yeah, WinWord, that's the process there. Okay, so if I see, that's Word, okay? So start it back up again. So the process is WinWord, okay? Now, let me create another Word document. Double click. See, I've got two Word windows open. Where are they? See, I have too many windows open at this point. Oh, I'm sorry, they opened up on my other monitor. I forgot they opened up on my other monitor. Okay, so there's two Word windows. Okay, but only one WinWord process. See, it's a little bit smarter program. It does not create a separate process for each of these windows. Okay, so here, if I close one of those windows, the process is still there. Okay, so if I click File, New Window, okay, see, I've got a new window, but I don't have a new process. Some processes are clever. They can create multiple windows within one process. Some processes are very simplistic and they need a separate process for every one of their windows. So Notepad is a simplistic one. Notepad needs a process for every window. Okay. Now, an interesting one is Chrome. Let me close these. I got so many windows open. Okay. Chrome is actually kind of odd. Like if I go to Chrome, I have right now I have 2 Chrome windows and 3 Chrome tabs. Oh, actually I have on my other monitor, I have a Chrome with 1, 2, 3, 4 tabs, and here I have a Chrome window with 2 tabs. So I have 2 Chrome windows, 1 window with 2 tabs, and here I'll pull that. Okay, now I've got 3 Chrome windows, 3 Chrome windows. One's got 1, 2, 3, 4 tabs, and these 2 have 1 tab each. Okay, now look at over here. But I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 Chrome processes. Why is that? People got tired in Chrome of having a lot of tabs open, and if one tab did something bizarre, all of the tabs would crash and Chrome would crash. I know maybe you guys don't remember those days, but it was just a couple years ago that if you had a whole bunch of tabs open in Chrome and one tab did something flaky, it could cause the Chrome to crash and you'd lose all your tabs. So the Chrome people decided that the better way to do it was to make each tab a process. So every tab is a process, but then there's another process that owns all the tabs. So it's kind of a weird mixture of how the way Word works and the way Notepad works. One of these processes owns all these other processes. And the other processes are the individual tabs. So for example, if I started creating tabs here, did you see? Oh, see, let me see. So notice how, look over here. Well, right now I have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 Chromes. Create a tab. Now I have 15 Chromes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, 16, 17. I created some new ones popped up. Yeah, Chrome is weird. It has its own notion of how to create these processes. And if I close that tab, see, one of the processes went away. So Chrome, the window is one process, and each tab is another process. If a tab goes dead, you can just close that tab. For example, I can just take a weird chance here. Let me see. If you just kill processes, you'll eventually see a weird tab. Let's see if I can figure out which one of those tabs. Unfortunately, it's hard to match processes to tabs. Let me just kill one more, see if I get lucky. You get a picture that shows a dead tab. I'm not getting, so I don't even know what I killed there. I killed something that doesn't seem to be too important to Chrome. Okay. If you should happen to find the process that is, say, that tab, and you kill that process, this tab gets a funny little symbol of skull and crossbones and say it's a dead tab because it lost the process. The tab doesn't go away. It's a funny, Chrome will leave the tab there, but it'll show you a weird little skull and crossbones in here that says that the tab has been killed. Okay. So Chrome is kind of oddball. Remember, Word managed to have one process, and all your windows were really subsumed into that one process. So WinWord, oh, I killed WinWord. Yeah, WinWord managed to have all the windows in one process. Notepad's real simplistic. Every window is a process, and Chrome is way more complicated. Chrome is a weird combination of processes. Some processes own the windows, some processes own the tab, and one process owns all of them. And actually, what's interesting is if you go over here, notice that there's this command line part. The command line part shows you a little bit about them. And these processes have very complicated command lines. Remember we've been talking about command line arguments? Notice that every Chrome process has a command line with lots of command line options. So see, this one says type renderer. I'm pretty sure that means that's a tab. So that's a Chrome process that's a renderer. See this one? That tab is important. That process is important. That's the link between Chrome and the GPU. So when Chrome needs to use the GPU to render something, it does it through that process. I wouldn't want to kill that process. I bet it wouldn't be a good idea to do that. This process that doesn't have a command line is probably the master one. I'm guessing that it's the one that owns all the other ones. Then there's like, see, like this one's a utility. I don't know what that process is doing. It's probably not owning a tab, but it probably does some other work. Okay, notice how there's all these command line options that were used when you create tabs. What Chrome does is it launches a new tab, and we're going to see it launches it on a command line with various command line parameters that tells that process what role it plays. Is it a tab? Is it something that's communicating with the GPU? So it tells the process which role it's playing and then gives it some more information on the command line. For example, tells it what language to be running in. You see, I'm running in English. So that's an option on the command line because Chrome can run in a whole bunch of different languages. Okay. See this next option, scale factor 1.25. That's the scale factor you get from the display settings. See, I'm running at the scale factor of 125%. My screen is running with a magnification of 1.25, 125%. Well, Chrome knows that because it was told that in a command line option. It said your device scale factor is 1.25. Okay, so Chrome, when I create a tab in Chrome, the master Chrome process launches a baby Chrome process and passes it a bunch of parameters on its command line and gives it information. Okay, one of the things we're going to see is that the command line is actually the heart of the operating system. Windows is not a GUI operating system. It's a command line operating system. The Windows operating system, like Linux, is built around command lines. Okay, and it's only because you're used to using it as a GUI operating system that you think it's a GUI operating system, but it's not. It's really a command line operating system. And everything the GUI does, it does it by building command lines. And we're going to see how to do that in a little while. But everything is done by building command lines and using command lines. For example, I can get rid of the GUI operate. I can get rid of the GUI. Okay. The GUI is this process here called Explorer. That process is the GUI. If you notice, I have all my programs running, but I no longer have a desktop. So I kind of have a GUI, but I don't have all of the GUI. Okay. See, part of the GUI is missing. Okay. Oh, what do you guys see? I was wondering, is Zoom totally screwed up at this point by any chance?
No, it's working.
Kind of.
It's working? Good.
Black, but we can see Notepad and Character Mat. So
Do you see these little floating weird icons?
Yeah.
Yeah, you see
Yes.
the little floating, those are the programs minimized that they should have been in the taskbar, but the taskbar is not there anymore. Okay. So I've killed the Explorer and I've got a blank desktop. Now I still have my programs running, but now the question is, like, how do I get new programs running? Okay. You know, you might ask, like, how would I get another program running? I have nothing to double click on. Does anybody know?
Could you right click and open a command prompt?
Pardon me?
Can you right click and open
No,
a command
I have
prompt?
I have nothing to click on. So even, yeah,
Control Shift Escape to do command prompt.
okay, Control Shift Escape brings up the task manager. That's actually the secret. No, you don't. Did you say bring up the command prompt?
Yeah, I meant Task Manager.
Yeah. I don't think there's a shortcut to bring up a command prompt, but you can bring the task manager is essentially actually more than the task manager is more the operating system than you realize. Yeah. So for example, if I kill the task manager, now I have no way of, what can I do? Well, I can do Control Shift Escape and the task manager will come back. So even if I kill the task manager, I can bring it back. Okay. Now, how do I get back my desktop? Well, the task manager can start processes. Whoops, no, I'm sorry. Options, no, file, run new task. File, run new task. Type a command line, like I'll type Notepad. Okay, so I can run Notepad. Okay. Now, right now, if I go here to details, there is no Explorer running. Okay, there's no Explorer running. But if I go here and if I run Explorer, it rebuilds my desktop. Okay, see, so the Explorer rebuilds the desktop. The desktop GUI is not Windows. The desktop GUI is this Explorer process. Now, see all these little funny icons down here. They stay funny icons, but if I maximize them and then minimize them, they go back into the taskbar over here. Okay, so they when you kill the Explorer, it doesn't know to grab these little guys back again. So you have to maximize them and minimize them, and then they go back into the taskbar like they should be. So I can maximize one, minimize one, and now he's back in the taskbar. So I got to do that to all these to get them back where they belong in the, or I can just kill them. Okay. I think there's one more hidden below. I think there's one more hidden behind my Zoom bar. Okay. All right. So processes are running. Oh, I was going to show you one thing. The Explorer program is in that Windows System 32 directory. Windows System 32. Okay. Then you go and what we're looking for Explorer. Oh, wait a minute. Oh, Explorer may be in one folder up. See, it's not here. EXP, expand. Okay, I think it's actually, yeah, it's one folder up. It's, yeah. Who decided this? I have no idea. A couple programs are in Windows folder, and the vast majority of them are in the System 32 subfolder. Okay, the vast majority are in here, but a few are up here. And a few are weirdly done, like Notepads in both. For some bizarre reason, they put a copy of Notepad in the Windows folder, and they put another copy of Notepad in the System 32 folder. And I think I know why. Probably many years ago, there was one copy of Notepad in this folder. Then somebody said, but it should be in this folder like all the others. So they put it in this folder, but they can't delete it from this folder. Why not? Suppose like Windows 2 had Notepad in this folder. And then they decided it really should be in this other folder where everything else is. So they put a copy of Windows 2 in this folder, but they don't delete it from this folder. Why would they not delete it from this folder?
Older files are using it.
No. Well, what do you mean? Why would anybody be using it?
Just how the previous versions were written that might be linked to that.
Right. There could be old programs that are used to the way things used to be, and Microsoft never wants to break old software. If you bought a program in 1984, it still runs on Windows. And the reason it still runs on Windows is because they never make breaking changes. So if Notepad used to be in this folder and they think it should be in this folder, they'll put it in this folder and they'll leave a copy of it in this folder. This copy is probably there for backwards compatibility. And then this is the folder where the new one is. See this program called Write? That's another weird one. If you run Write, you get a thing called WordPad. Okay, and that's because Microsoft used to have a program called Write, but then they replaced it with something called WordPad. So they left a program on a computer called Write, and what Write does, when you double click on this thing, all it does is it runs WordPad. So there is no Write program, but if you double click on this, it launches WordPad. And it's there for backwards compatibility because there used to be a program called Write, and then it eventually got replaced by WordPad. And WordPad, I forget where WordPad is not, if I remember right, in the System32 folder. WordPad's like a baby version of Word. It's like a free version of Word. Like Notepad's a free baby text editor. WordPad is a free baby word processor. And I think it's, if I remember right, it's in some weird place. Let's see if I can see if I find WordPad. No, there's no WordPad here. Yeah, if WordPad's somewhere strange. See if I can find WordPad. There it is. It's under 32-bit programs, Windows NT, which is an ancient version of Windows, accessories. There's WordPad. Okay. Why is it put there? I have no idea. And then the program called Write launches WordPad. Okay. And if you go over here, you can do WordPad. See, and you can, and it launches WordPad. So there's all kinds of weird things in Windows to keep backwards compatibility. Windows is really strange about having all kinds of bizarre, weird things so that programs from ancient days can still be run. So there's lots of strange things in Windows that make it so you have old programs can run. Okay, so now a program is a file on your hard drive. A process is a program that's been copied into memory and is now executing in memory. So every one of these programs, see now they're identified by their EXE file. So these are programs running and they're running in memory. So if I go here to the performance tab and I click on memory, that's what if I kill programs, I'll see the amount of memory use go down. If I start launching programs, I'll see the amount of memory use go up, because every time I launch a program, the process is loaded into memory and it'll use more memory. Okay. Some processes use very little memory, and some processes like Chrome are real memory hogs. They use quite a bit. In Task Manager, if I go back to the Details tab, I have this Memory tab that shows me how much memory a process is using. So the one Chrome tab alone takes up almost 200 megabytes of memory. Okay, that's just one of the Chrome tabs. Altogether, Chrome is probably using about a gigabyte. Usually Chrome runs in about a gigabyte of memory. Chrome really uses a lot of memory. So the largest Chrome tab is using 170 megabytes of memory. And then if I went through here and added up all these memory amounts, I would see how much memory Chrome is using. It's using quite a bit. Okay. Notice that CMD is the command shell is a process. Okay. So I've got one shell up here. Remember, I used it to launch notepads. See, remember, I used this one originally to launch notepads. Okay. Oh, notice if you type, oh, I'm sorry. If you type character map there, I can't remember if Windows isn't smart enough. Now let me try something. Windows actually is kind of clever about some things. Let me see if it's smart enough to figure that. No, it doesn't like it. You know how like you go over here and you can type character map. See, so it knows it by the name character map. Oh, if you go here and you type, if I go here and I type CHARMAP, it just says CHARMAP is, see, char map is character map. So it kind of knows, so I can either type the real name or I could type its formal name. At the command prompt, I don't think the command prompt's smart enough to figure out what character map is. Yeah. So you wouldn't be able to start character map from the command line unless you knew that it's called char map, unless you knew what its name was. Okay. Okay. Now let's go to the folder. Let's see. Let's go to Windows examples. In this folder, I put a program called Process Explorer. Process Explorer is a super fancy version of Task Manager. And it's written by Microsoft, but it doesn't come with Windows. You have to download it separately. See, it's from Microsoft, and you have, see this guy, Mark Russimovich? He's one of the lead programmers at Microsoft. Truly brilliant person. And he's in charge of the Windows kernel. He's like Linus Torvalds is the guy in charge of the Linux kernel. Linus Torvalds is in charge of the Linux kernel. He's the guy who's in charge of the Windows kernel. Okay, so he wrote a lot of Windows. Okay, so he wrote this thing called Process Explorer. Okay, but for some reason, it's not part of Windows. You have to download it. So I downloaded it and put it in this folder. It's a version of Task Manager, but it shows you a lot more information than Task Manager does. Oopsie, where is it? Oh, it took a little while for it to start up. Okay, here is Process Explorer. Okay. Okay, so now, see, it's showing me, now Process Explorer basically defaults to this detail view. See, Task Manager has all these other views. Okay, the details view of Task Manager is essentially the only thing that Process Explorer does, but it does a lot more. So it's like a super scaled up version of this details view. So it's showing me all my processes in a very similar kind of way. If I right click on one of these column headings, I can select columns. So I can add more columns. So see if there's any column I think, I want the command line column. Okay, and see, there's massive numbers of columns. I think right now, I think the only one I really want is the command line. Okay. Oh, I don't need company name. Let's see. Don't need company name. I picked different columns. Okay. All right. Now, let me show you something that's really interesting. I have a command prompt over here. Now, I'm going to close all my notepads. I'm going to close all my NS lookups. Okay. All right. This CMD is, where is it? Oh, here. There's CMD. Okay. I'm going to use this CMD to launch Notepad. Okay. Go here to View and say Show Process Tree. I forgot that wasn't by default turned on. Go here to View and click Show Process Tree. And now let me close Notepad. Okay. See, I have this CMD. That's this guy here. And I type Notepad. Oh, what's going on? I'm missing. Oh, I was looking at the wrong CMD. I'm not this. I think when I killed Explorer, I did some, things got a little bit messy. So let me minimize these. I'm minimizing some of this stuff to make it easier to see what's going on. Okay, this CMD is this guy here. Okay, now, okay. Now watch over here. When I launch Notepad from CMD, Notepad is now a child process of CMD. This is what we want to get at. This process created this process. See? CMD launched Notepad for me. On the other hand, if I go to the Explorer, oh, I have so many windows open, it's getting confusing now. Let's see, what do I want to do? There. Okay, that popped up in Explorer. Okay, and I want to go to oh, this PC. I want to go to my C drive, and I want to go to the Windows folder. Okay, and go to System 32, go to Notepad. Okay, now I'm going to launch another Notepad. Okay, I double clicked. Now, who launched that Notepad? Let's go to the Process Explorer. See, one Notepad was created by CMD. See, this Notepad was created by Explorer because I double clicked on a window. The windows we saw earlier belong to Explorer. This window is the Explorer process. When I double click on the icon here, the Explorer process launches the application. So if I go back here to char map and double click on it, I launched the process. If I look up here in Process Explorer, see, char map was launched by Explorer. If I go over here and I launch another char map, this one was launched by ECE. Okay. I can start another CMD here. Now I have one CMD that launched another CMD. And now this CMD can launch a Notepad. There is a parent-child relationship between processes. here's a real important fact. Every single process is there because it was created by some other process. Every process is the child of some other process. And if you look, that's what the tree view shows you. Okay, every process is a child of some other process, except for a few processes that make up the heart of the operating system. Okay, so there's a few processes that make up the heart of the operating system that weren't created by some other process. But otherwise, see, when you start Windows up and you get your desktop is the Explorer app, and then everything you start by double clicking is really a child of the Explorer app. Okay, so a program is a file on the hard drive. It's a compiled executable. A process is a program running in memory. Every process was created by another process. Okay, using the, remember what I said, it's like an object programming. You say, when you have a class, you say new class and you get an object of that class. Every process can create an instance of some other process. So CMD can create an instance of CMD. Then CMD can create an instance of Notepad. Okay. Notepad's not smart enough to be, Notepad doesn't know how to create processes. Notepad does not know how to create processes, but CMD does and Explorer does. So Explorer has a mechanism for creating processes and CMD does, but Notepad doesn't. Now, the real question is, what does CMD do to create a process? What is the new operation? Okay, what is it that they really do to create a process? And that's this folder, homework 2. That's your homework assignment. Your homework, there is a C function that tells the operating system to create a process. Okay, see this program here. This is in the homework 2 folders example. Open this C program. And what this C program does, we're running out of time, but we have a few minutes. I think we can start talking about this. It calls this function called create process. That's the new operator that takes a program and it launches a process out of the program. It instantiates a process from a program. It's the create process function. The create process function is it's a C function, but it's not from the C programming language. It's from the Windows operating system. It's a function. For example, this function does not exist in Linux. Linux has a different function for creating processes. It's called fork. So the fork function in Linux creates processes. The create process function in Windows creates processes. If you want to learn about the create process function, where's my, oh. See, here's a link to the documentation on create process, the create process function, which is part of the Windows operating system. So this is one of the most important functions in all of the Windows operating system because it's the function that all other processes call to create processes. This is the function that CMD calls when you type something at the command line. When you type Notepad here, essentially what CMD does is it takes that name, Notepad, and translates it into a call to the create process function saying, create a process out of Notepad. Okay. Okay. Now, the create process function is a very complicated function. It takes 10 parameters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parameters. Most of these parameters are, oh, now remember we talked the other day about in parameters, out parameters, and in-out parameters. This is where this stuff becomes important. Most of these parameters are a combination of in and in-out parameters. They are all pointers. See the LP, that stands for long pointer. Microsoft programming is weird, okay? And we're gonna have to talk a lot about this. if you look at this, this is a declaration of a function. Nothing in there looks like proper C. Okay, like here it says bool. There is no bool type in C. This thing says LPCSTR. Okay, what that stands for is long pointer to C string. To us, that just means chars. That's a string pointer. Microsoft gave names, their own names, to all the common data types in the C programming language. For some weird reason, it goes back deep into the history of their company. They decided to create their own names for all the C data types. Okay, so D word is a pointer to int. That's all it is. D word. It's really no. I'm sorry. It is an int. Now D word is an int. LP void is what we call pointer to void. This is a pointer to a string. Okay. This is a pointer to a startup info data structure. Okay, that's one of the things we're going to have to talk about. So that's a pointer to a data structure. So there's a huge amount of stuff going on here, but it's a C function that takes 10 parameters, almost every one of which is a pointer to something. And many of the things they point at are in-out parameters. Like this one is an in parameter. This one is an out parameter. This one's an in parameter. This one's an out parameter. I can't remember which. I think some of them are actually in-out parameters. Most of them are either in parameters or out parameters, and there might be one that's an in-out parameter. Okay. So there's a lot going on in the C language here. This is not a trivial matter. It's a function in C, but it's complicated. Now, over here, it turns out that when you actually use this function, a lot of those 10 parameters can be ignored. You can just pass a null to them. So notice that out of the 10 parameters, 1, 2, 3, 4, 5, I set to null. 1 I set to false, and I'm actually really only using 1, 2, 3, 4 of the parameters. I actually only really need to worry about 4 of the 10 parameters. Okay. Now in the homework assignment, this stuff is explained, and we're going to be talking about this quite a bit. But in the homework assignment, there is a discussion of these parameters. Okay, and this code here is an example of how to use it. Okay, right. So right now, for our point of view, we can ignore this, ignore this, ignore this. That means that we're ignoring this one, this one. Notice we're ignoring these things called security attributes. Our programs are we're not writing highly specialized code. We don't need to worry about security attributes. So we don't worry about this first parameter. Command line is our important parameter. See the second parameter is called command line. That's what I meant when I said that the Windows operating system is really at heart a command line operating system. Create process takes a command line in order to create a process. Okay, so that's one of our important. Now up here are my command lines. See here I have an array of command lines. Okay, and then here I'm going to pick one. I'm going to iterate through the array of command lines and give create process one command line at a time. Okay, so we need the command line. That's important to us. We can skip the security attributes. We're going to skip that. Let's make this one false. You'll use this one in the homework assignment. So there's an example of using it here. Won't need to use these. See this one environment? That's where the environment variables are. We set this to null, which means we're accepting the default environment variables. That means that our program is going to use the environment variables of the shell that it was called from. But Windows allows you to create a process with an entirely different set of environment variables. So this is a pointer to an environment that lets you start a program with a unique set of environment variables. Okay, so you learned in the first homework assignment about environment variables. Here's where they're part of, you see it's part of create process. Environment variables are part of create process. When we set that to null, we're using the environment variables that you get when you do something like set Bob equal Alice. So I just set that environment variable. These are the environment variables that my process sees automatically, the ones I create here. But if I wanted to give my process a wholly different set of environment variables instead of these, I could, if I know what I'm doing, I could create an environment and pass it to create process. But we don't need to do that. Okay. Then current directory, we set the null, which means the current directory is whatever directory this command prompt is in. Okay. And then what's real important in the homework assignment is these last two, the startup information and process information data structures. That's where the hard work is going to be. These two guys here are the kind of complicated things. So we need a string that's a command line. We'll say a little bit about what this is later. And the hard part's these two guys. Most of the work you do in the homework assignment is you're going to have to learn about what's a startup information data structure and what's a process information data structure. This one is an in parameter. This one's an out parameter. Notice that, see, they're both called with an ampersand. They're pointers. This one is passing information to create process. This one is used by create process to pass information back to you. So you pass information to create process gives you information back. In parameter, out parameter. Okay. Okay. Now let's just, when we run this program, it's going to pop up a notepad, a char map, and an NS lookup. See, it points to their location on the hard drive, and it just tells Windows start them up. So let me see if I can run these. Let's see if I can do this one last thing. I need oh, I know what to do. I want to compile this program. So I'm going to compile it the hard way, but it's a nice way for you to see how I do this. Open a command prompt. The compiler I told you about is in your hard drive. So CS302 min.gw, the binary folder, GCC. There's the compiler I gave you. Okay, I'm going to call that compiler directly. Okay, and I'm going to compile create process. Okay, now with GCC, I need to tell it what I want the name of the compiled program to be. So I say -o. Now this is what the editor normally would do to you. No, yeah, create. You know, I don't have to call it that. If I wanted to, I could call it I just compiled this program to Bob. Yeah. The EXE doesn't care what it's called. This is not Java. In Java, the class file has to name the same name as the class, but this is just, you know, now I can run Bob. Bob called create process 3 times, launched the char map, launched NS lookup, and launched Notepad. And then it went into a loop where it says, here's some information. Now go over here to Explorer, the Process Explorer, and we can go down here and we can see that my command prompt launched Bob, and Bob launched Notepad, char map, and NS lookup. Okay, so my command prompt, I used it to launch the Bob program, and the Bob program launched the Notepad program. Okay, now what's interesting is if you hit enter here, Bob goes away. See how it turned red? Now Bob went away. That means that these processes are orphaned now. Their parent went away, but they don't die. But notice that they now become parents. They've switched to being root processes. They no longer actually have a parent process. This is how you end up with processes without a parent. You kill the process's parent. then the process ends up being at the top of the tree without a parent. Notice that they did not go up to their grandparent. That was their grandparent process. CMD created Bob. If I do that again, here's another call to Bob. CMD created Bob. Bob created Notepad. If I kill that Bob, Notepad doesn't go up to his parent. Notepad goes over here to the top level. It no longer has a parent anymore. So if I now kill Bob again, if I can find him, by hitting enter, that terminates Bob. And now what were Bob's children go back to being just, they don't have a parent anymore. Okay, so create process is the heart of the operating system. That's how processes end up running. Every process that's over here, every single process here was created by some other process calling create process. When you double click on an icon, it's the Explorer that calls create process. When you go over here and you type Notepad, that's still Explorer. See, the start menu belongs to Explorer. So when I click on that, that was created by Explorer. So if you double click on anything on your desktop, or if you use the start menu, then you're using Explorer. If you bring up a command shell, then you're using CMD. CMD calls create process. And the other one that can do create process for you is Task Manager. So if I go here and I do File, Run New Task, Notepad, then I get a copy of Notepad that was launched by Task Manager. And I don't know if we can, let's just look, see. Then Task Manager that's this Notepad here. This Notepad here got run by Task Manager. Notice the Task Manager, oh, remember my Explorer was launched from Task Manager. Remember when I killed Explorer, I launched a new Explorer in Task Manager. So now this Explorer is my desktop. And I used Task Manager to launch. Oh, that's this Notepad. Oh, that's this Notepad, the one I just launched. Because see, Task Manager launched Explorer. And then the Explorer was used to launch some other things. But this Notepad was launched by Task Manager, not by Explorer. Okay. And this Notepad, no, this Notepad was launched by, I guess, Explorer. This Notepad was launched by Task Manager. There. This Explorer was launched by Task Manager. Okay, so you can read the tree and you can see, but every process was launched by some other process. Okay, we should quit. We're going over time. There's a lot of stuff going on here. Okay, so we're going to keep playing around with these ideas of processes, looking at processes both from the Explorer point of view and from what's real important is the programmer's point of view. There's the programmer's point of view of process. That's the new operator. That's new. Create a new process. Instantiate a process from a file on the hard drive. Okay, so we'll quit there. And we'll see what day is it today. So on Monday, we'll do more of this again on Monday. Okay. And if you have questions about any of the stuff we did today, just send me an email. And if you have a question about any of these weird things we did, just send an email and ask. Okay. So I'll end the meeting now. Bye.